Okay, our next idea here is still with functions. We're going to look at how to identify some key pieces of a function, some key elements of a function off of a graph. So we have a function here, and I know it's a function because if I did my vertical line test, I would never hit the graph two times at the same time. So I never hit the line twice. All right, now we want to identify the domain and the range from the graph. Now we talked about this all the way when we first began. The domain is what you can put into the function. The range is what you can put out. Now, not all functions cover every number in the world. If you look here, this one doesn't cover everything. It doesn't go on forever. So if I were in a classroom, I would normally do this with a ruler here. But so if you want to find the range, that is supposed to be a ruler, if you want to find the range, you're going to go up the x-axis. Now we read from left to right, so we're going to do the same. So we're coming from the left over to the right, this direction. We're going to go up the number line. And the domain are the x's, so we're going to begin our domain when we hit a number. So this graph isn't the best. But you see, if I was moving this ruler, I would start to hit the graph at this number, which is -3. Now, in interval notation, if you remember this, interval notation says I want the number 3 because it's filled in. The circle there is filled in. So if we want to include a number, we give it a bracket. So I want to include the number 3, and I keep on going here, and my ruler would still be hitting until I get to the value of +3. And we have a filled in circle there as well, so we're going to say, hey, we also want that number. You keep on going, there'd be nothing else. Now that's the domain. Okay, I'm going to designate that with a D. Now let's do the same trick here, but now we're going to go up. We're going to go up the y-axis from the negatives up to the positives. Now if I'm moving, now people get really confused by this, but only concentrate now on the y's. You're going to move the ruler up. You would hit something with your ruler when y is -1. Do you see what I'm saying? I would hit here. Now don't read the x's, you're reading the y's. I'm reading that -1 right there. And it's a filled in dot, so we would want it. -1, so we give it a bracket. You keep moving your ruler up, you'd be hitting stuff, all the way up till 3. You're still hitting something. It's only the y values I'm interested in now. So up until 3. It's a filled in dot. And so I have found my domain and my range by starting with the graph of a function. Now let's try another one here. You can always, if you think you already got it, you can pause it and do it yourself. I'm going to get started here. Here's my domain and my range. I am moving my ruler up the x-axis. And when I'm here at -5, I would first begin to hit something. And it is a filled in dot. Like that is a dot I want. I hit that, so I'm giving it a bracket. Keep moving my ruler, keep moving my ruler. I only care about x's. At 1, I hit something as well, and that's the end. At 1, an x of 1, it's a filled in dot, so I'm giving it a bracket. Now, we're going to move our ruler up the y's. I only care about y values. If I hit anywhere, that's good enough for me. So I come up here, I get to -4, and I hit something. Keep on going, all the way up to 2. And I don't know if, I think we'll have some open circles sometimes. Sometimes you can have an open circle that says you're going to stop there, but you didn't want that point. That would be a parenthesis. I don't know if this textbook's going to do that. Yeah, so far this looks like it's going to be all filled in ones. So we'd have all brackets. Okay, definitely like you to pause. Try this video, or this one here. Let me try it. We're going to take that ruler. We're going to go up the x's. I hit something, just the x values, that's all I care about. Hit something at -2. Keep on going, I would stop hitting at an x value of 4. They're filled in circles on both ends. Now, only the y's. I'm going up the y-axis. I'd hit something when y is -5. It's filled in. Keep going until I get to 3. It's filled in. So if they don't show a dot there and it just hits, we're going to assume that means it's filled in. The only time you'd assume you don't want to point is if you hit just an open circle. Okay, now this is really crowded and I don't know if this is the best function to begin with here, but we've got this curvy line, which you're going to see in trigonometry, and we want to read it. Yeah, I don't know that I would have started with this, but that's okay. So when we put 0 into this function, we want to know the values that come out. So when x is 0, what do we get? Well, that means 0 is going into the machine. So when x is 0, the y that comes out, its partner point, is 0. Now, we want to put in 3/2 pi. Okay, that's an x value going in. That would be here. Well, what is the value that comes out? What's the y value? It's -1. So that would equal -1. Now, how about -1/2 pi? That's back here. That's an x value, -1/2 pi. Now, what's the y value that goes with it? That's what this is asking. It's also -1. Okay, now this is going to ask us to go in the reverse. This is saying, okay, we get a y value of 0. When does that happen? Okay, well, a y value of 0 is up and down, we're at 0. So what x's have a y value of 0? Well, we'd have that one, this one, this one. It actually will keep going on forever. So what values could you put in that would get a y value of 0? Well, it's all of these. It'd be -2 pi, -pi, 0, pi, 2 pi. So again, pi, this is a really unusual one to start with here, but I'm trying to find out when I would get a 0 out for the y. Well, 0 on the y is right here, and this is essentially called the x-intercepts. Where does it hit the x-axis? So it's all of those points. Okay, now what are the x-intercepts? Well, that's exactly the same thing. The x-intercepts are where y is 0, so that is identical to this. Now, x-intercepts are points, so make sure you give them to me as points. For instance, this one here is, again, I don't like that we're starting with pi, but pi 0. Okay, that is the point. That is one of the x-intercepts. -pi 0 is one, -2 pi 0. You have to give them as points. Okay, y-intercepts are where we hit the y line. That's where x is 0. So if x is 0, where do we hit the y line? We actually already found that as well. That's the point, 0, 0. Okay, now how about the domain and range? This one is a little interesting. So I'm going to take my ruler. To find the domain, I'm going to start moving across this to the right. Now, because it has the arrows on the end, this means it goes on forever, just keeps going up and down like a wave. So I'm actually going to hit something everywhere along the x-axis. And the way we would write that is -infinity to infinity. Now, before I was telling you we kept using brackets. Well, you can never reach -infinity or infinity. So you give it a parenthesis. It's like it can never be reached, so we can't get there. It can't be a bracket. So that's my domain. Now my range, we're going to take our ruler and we're going to go up here, up this line. And we first start hitting something at our y value. So remember, we just care about the y value when y is -1. And we want -1. We're hitting something, a dot at -1. We keep hitting, keep going up until we get to 1, just the y value. We want that, and so we give it a bracket. Okay, I'd really recommend you try this on your own. Pause the video, but I'll work it for you. So we're doing basically the same thing, and again, we've got pi. It doesn't have to be, you could have just a normal looking function. I don't love the choice of this, but so same thing. If you get 0 in for x, what do you get for y? Well, you get 0. If you put 1/2 pi in for your x, that would be right here. What y do you get out? Well, you get 2. If you put negative 3/2 over pi in for x, that's here. What y value do you get out? Well, once again, you get 2. Now, what values give you a y of 0? Well, those are the x-intercepts. Those are the same thing. So that happens at 0, 0. It happens at pi 0. It happens at 2 pi 0. And it would actually keep going off the chart here. So x-intercepts are when y is 0. That's all of these. It's where we hit the x-axis. So D and E here are the same thing. They're synonyms. Okay, the y-intercepts are where do we hit the y-axis? Well, there's only one place. Now, y-intercepts are when x is 0, but it just so happens it's the origin, so we'd get 0, 0. Now, our domain, we're moving our ruler across up the number line. We're hitting everywhere on this one. It'd be negative infinity to infinity. Now, so that's my domain. My range, I'm going to take my ruler and I'm going to start going up the axis. I would first start hitting something at negative 2, and we want to include that. And we would stop up here at 2. So it gets brackets. Okay, got one more of these if you're interested. Again, I don't know why they're doing these kind of, it could work for anything. We don't have to have pi involved, but so 0 for x, you get out 0 for y. 1/2 for pi for x, you get, is this the exact same question? It looks like it. Negative 3 pi over the 3/2 pi, you get a y value of 2. Once again, where do you, these are synonyms. X-intercepts, and when do you have a y value of it equal to 0? Same thing. So, but give me these as points here because they're asking for the intercepts. Negative 2 pi, 0, negative pi, 0. You keep going. I'm just every place where I'm hitting the x-axis. Okay, y-intercepts once again. It could be any number. They just keep doing this where the y-intercept happens to be right here. Where do we hit the y-line? That's when x is 0. It happens to be the origin. Domain, we're moving across. Once again, we get negative infinity to infinity. And the range as we're moving up, once again, is, I don't know if that was exactly the same problem as the one I just did. I'm not sure. It'd be negative 2 to 2. Okay, again, I don't know why they wanted the wave function all the time, but you could do all those same ideas off any function graph. And a function is graphed if it passes that vertical line test. So remember, the x-intercepts are when y is 0, and y-intercepts are when x is 0.